Course 3, Lesson 111. We are looking at spheres today and looking at how do we find the volume and surface area, especially because spheres actually come from the formula for a cylinder. Let's actually look at how these are related. So using lots of proofs and math that we're not going to get into today, mathematicians have found that, just like we looked at a little bit ago, that the volume of a cone is a third of the volume of a cylinder. Okay? Now a sphere is actually 2/3 of the volume of a cylinder. Now with the cylinder, we are assuming a couple different things. Number one, we are assuming that the diameter of this circle on our base of our cylinder is the same as the height of the cylinder. It may not look like it in this one, that's okay, but that is what we're assuming. If this was 5 inches, then the height would be 5 inches. The reason being is because if my sphere fit perfectly in there, we would be assuming that from the center of that sphere going in every direction you can think possible, we would have the same distance. In this case, a distance of 2.5. Okay, so when we assume that this cylinder has to have the same diameter as the height, that's the reason why. Otherwise, we wouldn't be able to assume what the volume of that sphere would be, because it wouldn't really be a sphere. It would be kind of squished. It would be oblong. So when we do this, when I find the volume of a cylinder, I am actually saying volume equals 2/3 of this volume. So area of the base times the height. Okay. If you were to think about it, if I were to add these two together, if I were to fit them in the same cylinder together, it would actually be the same volume as this guy. Okay, 1/3 plus 2/3 equals the total volume of that cylinder. They actually both would fit in there, which is pretty amazing. So how we get our formula for this, that is a little bit of a simplified version of our volume formula. You can absolutely still do area of the base times the height and then take 2/3 of it, but we're going to simplify things a little bit. Okay, so first of all, when I find the volume of our cylinder, I do area of the base, so pi r squared, times the height. Now I could assume a couple things. Since we know that our diameter is the same as the height, I could say, well, if this is just diameter, I could also replace it with 2r, 2 radiuses. You can think about from the middle of that sphere, if we had a sphere in here, from the middle of the sphere, we would have a radius and another radius. So 2 radiuses is the height of this cylinder. So I simplified to get 2 pi r cubed. Interesting that we can also assume the volume of a cylinder that's the same diameter as it is the height. But we go a little bit further. If we want the sphere, we say it's 2/3 of that volume. So we take 2/3 and multiply it by the 2 pi r cubed that we just got. Remember that 2 pi r cubed, that comes from just taking this r right here, multiplying by that r squared. So 2 pi r cubed, we multiply by 2/3, and we would get 4/3 pi r cubed. And that is the volume of our sphere. That's where that formula comes from. Maybe you've seen it before, but that's why we have it, is because the sphere, from the center of it, every single distance to the outside edge of this is the exact same, we can assume this formula for the volume of a sphere. So let's practice with it. So if I had this ball that has a diameter of 20 centimeters, what is the volume in cubic centimeters? So let's write down our formula. V equals 4/3 pi r cubed. So let's plug in what we know. 4/3, and we're using 3.14 for pi, and then my radius. Well, my diameter is 20, so my radius must be 10, and we cube that. So I am actually taking V equals 4/3 times 3.14 times 1,000, which is 3140. Okay, and then when we actually take 4/3 of that, we'll round afterwards, but when we take 4/3 of that, we get 4,186.6 repeating, or I'll put it as a fraction here, 2/3 centimeters cubed. Okay, so to finish this, it says round to the nearest 100 cubic centimeters. So we would round and say it's about 4,200 cubic centimeters. Okay, just going from the formula that we have created from our original cylinder. Okay, now the surface area of this. The surface area, what it comes from is actually taking a cross section of our sphere. You can see by this picture, if I were to take a sphere like an orange and cut it perfectly in half, in the center there would be this perfect circle. If I didn't cut it perfectly in half, then one side of the circle would be different than if I cut it differently. So we do want to cut it straight down the middle. And when we find the area of that type of circle, we would just use our normal pi r squared. Well, when we do cut it directly through the center of the circle, that is called the great circle. Think about if you had a sphere. If I cut it straight down in the middle, great. That is called our great circle. Okay, but I'm not cutting it over here or over here because that wouldn't give me the perfect that perfect circle that I'm looking for right in the middle of our sphere. Okay, so I really am looking for that middle one. Well, mathematicians have found out that with a sphere, the surface area of that sphere is actually 4 times the area of that great circle. So I take the area of this middle of my orange and multiply it by 4, and I get the surface area of the entire sphere, the entire outside of it. So basically the orange rind all the way around, if I were to figure out the area of that entire orange, it would be 4 times the area of the center circle, area of that great circle. So let's try it with something like this softball. The diameter of a softball is nearly 10 centimeters. Find the surface area, express your answer in terms of pi and using 3.14. So let's start out figuring it out in terms of pi. So I'm going to use my surface area formula that says 4 pi r squared. So I just plug in what I know. 4 times pi times r squared. Well, the diameter is 10, so my radius must be 5. And I square it. So I have surface area equals 4 pi times 25, meaning that I actually have a 100 pi centimeters squared surface area. Now that's in terms of pi. If I want this as a decimal, I would just take 100 times 3.14, and we still have centimeters squared. So as a decimal, it would be 314 centimeters squared. So just using what we know with our formula in order to get that surface area. Okay, continuing on, I believe we just have a couple more here. So surface area and volume of this sphere that has a diameter of 6 inches. So when we do this, let's do the volume first, let's say. And I'm going to use my formula, 4/3 pi r cubed. So plug in what you know, 4/3, and we're leaving pi as pi. And then my radius is 3 that we're going to cube. So I get a volume of 4/3 times pi times 27. Well, I'm going to put this 27 as a fraction because I see with this fraction over here, I can simplify some things. And I end up just getting 36 pi, and I'm in volume, so inches cubed. Surface area is not any more difficult. So 4 pi r squared, and I get 4 pi times 3 squared. In this case, funny enough, we end up getting the same looking surface area, 36 pi, but in this case we're in inches squared. We're looking at that surface area. All right, last one that I'm going to show on this video. Pretty straightforward lesson here. So surface area and volume of a sphere that has a diameter of 30 centimeters. So volume, 4/3 pi r cubed. So in this case, it doesn't want us to leave it in terms of pi. We want to use 3.14. So we do 4/3 times 3.14 times a radius of 15 that we're going to cube. I'll give you a second, pause the video and work all of that out, multiply everything out. Take a second. But when you do, we find a volume to be 14,130 centimeters cubed. Surface area, we're just going to plug in very similar way. So 4 pi r squared, we get a surface area of 4 times 3.14 times 15 squared. Once again, take a second to pause the video and try this out. Find that answer. But when you do, you will get 2,826 centimeters squared. All right, well, I hope that you have a little bit more understanding of where we get our formulas for surface area and volume of a sphere, and I hope this video helps you with your homework and with studying.